textbook problems. Now we are going to discuss about textbook problems in this chapter Chemical Equilibrium 2. Already we have done one problem D18. Now we are going to do D19. That is section D, 19th question. In your textbook, in section D, we are going to see 19th question. I will read that question. In equilibrium, H2 plus I2 gives 2Hi. The number of moles of hydrogen, iodine and Hi are 1, 2, 3 moles respectively. That is, I will write data first. Okay. Data. The number of moles of hydrogen, iodine and hydrogen iodide have been given. So, number of moles of hydrogen, iodine and Hi. 1, 2 and 3 moles. So, number of moles of hydrogen, iodine and Hi have been given. Total pressure also given. So, total pressure P equal to 60 atm. Then calculate the partial pressure of hydrogen, iodine and Hi of them itself. So, look at this problem. Number of moles of hydrogen, iodine and Hi have been given. Pressure is given. You have to calculate the partial pressures of hydrogen and iodine, of course, hydrogen iodide. Let's find this. Let's see partial pressure of hydrogen first. What is the formula for partial pressure? Total pressure into mole fraction. What is the total pressure here? 60. So 60 into, shall we calculate the mole fraction of hydrogen? How many hydrogens are there? 1. So 1 by, totally how many moles? 1 plus 2 plus 3, 6 moles. Once again I am telling, partial pressure of hydrogen means total pressure into mole fraction. Total pressure 60 into number of moles of hydrogen is 1. Total number of moles is 1 plus 2 plus 3, 6. Shall we cancel 6 and 60? So 10 atmosphere. Then partial pressure of iodine in the same way. What is the total pressure? 60 into. How many moles of iodine? 2. So 2 by total number 6. Shall we cancel this? 20 atm. Atm means atmosphere, unit of pressure. Then partial pressure of hydrogen iodide. Total pressure into how many hydrogen iodide? 3. So 3 by 6. Upon cancelling, you are getting 30 atm. That's all. Partial pressure of hydrogen has been found, 10 atmosphere. Iodine and the top Hi have been found. Shall we proceed? Shall we go to the next sum? That is T20. Question number D20. Section D, question number 20. I will read that. In 1 liter volume, that is V equal to 1 liter, data. V equal to 1 liter. In 1 liter volume reaction vessel, the equilibrium constant Kc for the reaction, PCl5 gives PCl3 plus Cl2 is 2 into 10 to the power minus 4 liter power minus 1. So Kc equal to 2 into 10 to the power minus 4 liter power minus 1. What will be the degree of dissociation assuming only a small extent of 1 mole of PCl5 have been dissociated? You know very well here that Kc can be written as x square by V. What is the formula for Kc? X square by V. Shall we rearrange for x square? X square equal to Kc into V. Up x can be written as root of Kc V. Shall we substitute Kc and V? 2 into 10 to the power of minus 4 into 1. That is x equal to root 2 into, how will you take root for 10 to the power of minus 4? You are taking half of the value. Half of the minus 4 is 10 to the power of minus 2. So x equal to, what is root 2? You could have been very familiar with this. 1.414 into 10 to the power of minus 2. That's all. This is the final answer. So for this question, this is the answer. X equal to 1.414 into 10 to the power of minus 2. Of course, it has no unit. Let's go to D21. Now the question number is D21. At temperature T1, the equilibrium constant of the reaction is K1. At T1, Kc equal to K1. This is given what thing. At a higher temperature T2, at T2, Kc is, K1 is 10% of K1. That is K2 equal to 10% of K1. 10% of K1 means K1 is decreased. K1 is the Kc for T1 temperature. K2 is the constant for temperature T2. Here T2 is the higher value. T2 is larger than T1. So this is given. So shall we take this one? K2 equal to 10%. Shall we write 10% as 10 by 100? K1. Shall we cancel this? So K2 equal to 1 by 10 is nothing but 0.1 is K1. So look at this, which is very large. The K1 is large. So K2 is smaller than K1. Whenever K2 is smaller than K1, it is called exothermic reaction. So they asked you to calculate, actually to predict whether the equilibrium is endothermic or exothermic. Here K2 is less than K1. So the reaction is exothermic. Understood? Shall we go to D22? Now we are going to see D22 question. The question number D22. At 35 degrees C, the value of Kp for the reaction, one reaction is given. N2O4 equilibrium gives 2NO. 2NO2. They gave the Kc value. What is Kc? Equilibrium constant in terms of concentration. 3174 atm. It's a Kc value. Kc, they gave it as Kp. Make it as Kp. atm. Kp means equilibrium constant in terms of partial pressure. Calculate the degree of dissociation when P value is given. P equal to 0.2382 atm. Kp value is given, P value is given. We have to calculate. You know very well that in the case of this reaction, Kp can be written as 4x square P, where P is the total pressure. Rearrange to get x square. Of x square equal to Kp by 4P. Kp by 4P. Substitute all the values. What is Kp? 0.3174 by 4 into 0.2382. Take the log of numerator and denominator and subtract. Finally, you are getting 0.33. It's x square value. If you take root of this, x equal to 0.5770. D23 question number.